Hey everyone, in this video, I'm going to show you how to run your Python scripts in your GitHub Action Workflows. There's a lot of information kind of all over the place about how to do this, so I thought I would condense the most useful and relevant information on how to do this in one video. So hopefully it'll save you a little bit of time and make your life a little bit easier. So in this video, I'm going to show you 5 different things. First, how to use your GitHub Action secrets with your Python scripts, how to run the script with the setup Python action, how to run it with PowerShell, how to run it with multiple versions and operating systems, either at one time or in parallel. This is super useful if you want to test your script in multiple Python versions like 3.9, 3.10, and different operating systems like Ubuntu, Windows, to make sure that your script works with all different environments and Python versions. I'll show you how to do that. And the last step is how to actually cache Python dependencies. This is really useful if, let's say you run your workflow and this script that you're using installs, let's say, like 10 packages. Like it installs, pandas, NumPy, and a bunch of packages and modules. What this will do is actually cache those dependencies. This is great if you run your workflow a lot. So if you run your script a lot, instead of having to reinstall all of those 10 libraries every single time you run the script, it can actually, you install it the first time, and then the second and third time and so on. When you run it, it actually will grab that saved information and not have to reinstall all those libraries again. So it'll save you a lot of time, and it's super useful. I'll show you how to do that. So let's get going. All right, so the first part I'm going to show you is how to use GitHub Action secrets in your Python scripts. So first, if we go up to the top here of my repository, we just called GitHub Actions Python. I'm going to go into settings here, go into secrets and actions, and then if you see, I have a couple of secrets added here. And secrets are really useful if you want to encrypt certain data, like usernames or passwords or anything you don't want people to see in the workflows or in any of the logs when you run your workflows. So this will actually encrypt the information that we list here. So for example, this is using Azure information here. If you're not sure what Azure is, this concept will apply to any secrets that you save. So like if you're using AWS or like regular Python scripts or whatever you're using, this is going to apply across. But you can think of like this client ID as like the username. This is the password, right? So we want people to see this. So then how does this work with our Python? How do we use these with our Python script? So if I want to actually use this resource group name in my Python script and do something with it, how do I do that? To be able to do that, what we're going to do is we're going to go to our workflow first. And I have this workflow called runpython.yaml. And the basic structure is you have the name of the workflow, which is this run Python script. This is the on is just when I want to run, like when do I want to actually run this workflow. And this is actually run, this workflow dispatch means, it just means that I can manually run this workflow. I can actually click a button and it'll run the workflow. You can do like pull, push requests, whatever you want to do. And this is the first step to be able to use the secrets in your Python script. Is you're going to create this environment information here. This just means we're going to create environment variables in our workflow. And if you see here, I'm creating subscription, variable, environment variable, tenant ID, and all the names that we had in our secrets here. And if you see, this is how we actually access that secret to create the environment variable. It's this $ bracket secrets dot and then the name of your secret. If you remember, we had that subscription ID, right? That listed here all in uppercase, and it is case sensitive here. We have like tenant ID, right? That username and password that I want to use. And again, this is all still encrypted, but this just means that we're able to actually access it. And I have it listed outside here under this on, outside of any jobs, because I want all of the jobs to be able to access these same environment variables. That means that in these different jobs, like this first job is run Python, the second job is run PowerShell, any of these jobs can use these environment variables. If I only wanted one job, like only this job to use these environment variables and not these other jobs, I can just copy this information and place it under this like runs on, kind of before the steps. So you can only use it in only that job. Now, the next step of how to run it is in your Python script. So in this first job called run Python, I have this Python script called my Python script that I'm actually going to run. So if we actually go over to that, this my Python script, this is how we access the variables. So the first thing you're going to do is import the operating system module in Python. It's a standard Python module. Here, I import a couple other modules of what my script's doing, but if you just want to access secrets, you only need to import this module here. Then the second piece is we're actually going to create variables in Python and then use those environment variables from our GitHub Action Workflow. So if you see here, I have this subscription ID variable. And what we're going to do is actually use this os.environ subscription ID. So what this is saying is I want you to grab the environment variable named subscription ID. And if you remember in our workflow, right, we created that environment variable called subscription ID. This was called like subscription ID 2. That's what you'd put here. You can still put subscription ID, but here you put subscription ID 2, saying we want to access that environment variable. And then I did that for the remaining ones here. So like tenant ID, I'm saying use the tenant ID, right? Environment variable we just created here, and I want to actually grab that information, okay? And then what this script does is it actually does some stuff in Azure. And if you're not familiar with Azure, don't worry about it. This will be, again, the concepts will apply to any script that you run. But in case you're curious about what this actually does, all this is going to do is in Azure, it's going to acquire an access token, which is like just the authorization and permissions to be able to do stuff in Azure using my service principal, which is like that username and password that I have listed here. Then it's going to create an integration runtime in a Synapse workspace called like my new IR1. So in this Synapse workspace in Azure that I have here, it's just going to create like an integration runtime, listed down here when we actually run this. Again, if you're not familiar with it, don't worry. Just want to tell you what kind of this thing does. And if it fails, it will raise an error. And if it succeeds, it will print out the content of what it does. And the last part of this script is if you see here, I put this in this $_name is equal to $_main. And I wrapped it in this main function. All my logic in this main function. This is really useful because if you have other developers looking at your code, what you're saying is this script can be directly executed. That's what this name does. So if you try to import this script into another file, like import, this Python file, it won't do anything. It'll only run if you run it directly. That's what you're telling other developers, that you can actually run this script directly. So it's just super handy. All right, and now you can see that in this Python script, these variables that we used here to grab those environment variables, we're actually using in our code here. So we're using like client ID, client secret, right, the name of the workspace, and so on to do that. So let's see how this actually works. So if we go into actions, we can go into one of the workflows that I ran. And to run this, simply click on the workflow. And I have this workflow dispatch, means it's a manual trigger, and click on workflow here. And now we can go into one of them. So what I'll do is I'll show you the first job that we ran. So I have a couple jobs there that I mentioned. And this first job, all it does is it's this run Python. It's named run Python. And then it's using the Ubuntu operating system. First thing we're going to do is it has a couple steps. So the first step in the job is we're going to check out the code. This is really important so we can download all the files and scripts that we're going to use and actually find our Python script. And then we're going to use this setup. And that's that second bullet that I mentioned in the beginning of the video about this setup action. You can think of actions as like prepackaged code that you can do some cool things with. So in this action, we're going to use the Python version 3.11. You can change it to 3.10, 3.9, whatever version of Python you want to run your script with. And then this last step is just it's called run Python script. And this little pipe symbol just means we're going to have multiple statements down here. And we're just going to say, all right, first install a request library and then run the Python script. And I list it as just the Python name script here because it's in the root of our directory. So if I go back here, that's because the script is listed here in our home root directory. If I had a folder here, so like for example, if I had a folder called like folder 1, and I had a Python file called like main.py, right? Okay. Okay. So if I had that like, here, and I had this file and I wanted to run this Python file, all I would do is in the code here, I would actually just do folder 1. So I would comment it like this. Folder 1 and then slash. So just so you know, you always start from the root directory of where you want to access your Python files. And now, that's all that's going to do. So now, if we go to our action now, I'll show you what this first one does. So if you see here, again, we check out the code. And if you see, it's going to use the environment variables that we had set up. But if you see, they're all asterisked, meaning they're all masked. So again, because those are secrets, you still can't see the values, but the Python script is actually still able to use those kind of under the hood. But it's still secure and safe, so nothing happens there. Then if you see here, so we check out the code, we set up Python, we run that 3.11 version we wanted to use. Again, it's going to use those environment variables that we had set up, and it's going to run the script and install the request library and any dependencies on the request library. And then if you see, our script ran, and then it successfully created the my new IR in Synapse. And if you see here, the information, even the returned value, right, the subscription name, is still asterisk because it's an encrypted value. So it's still, even the return value is going to be encrypted in any of the logs, so it's super safe. So if we go to Synapse here, you'll see the new IR was created, and this is the second script that I ran that created this one, but the new IR was created in this one, so it actually created that successfully. Now, how do you run, so that's how to run these first two things. To use the action secrets, and how to run the setup Python action. Now, how do you run it with PowerShell? So what you can do is back in our action, you'll see that in our file, in this run Python via PowerShell, this is the second job we have here. And then it's going to check out the code because this is a new job. So anytime you have a new job, a separate job, you need to kind of recheck out the code. And then it's going to run the script, is this step in the PowerShell shell. And so again, in multiple lines, run request, and again, just run that script again. This is running the second script, this PowerShell Python script that I had earlier. That's just going to create that second IR. So no big deal there. And now, when we run this, the difference is that if you see here, it's going to use the PowerShell terminal versus in our first job, it actually is going to use the bash Ubuntu terminal. So if you had a requirement to run your script in PowerShell, this is how you can do it. All right. Now, to our third bullet, fourth bullet, how to run multiple versions and operating systems either at one time or in parallel. So how this piece works is in our workflow file, I have another job called run Python multiple versions. And I had this where it needs these two jobs. Same thing up here, I had this. All this means is that it requires this job to run first before it runs this job. So this means this job, this run Python job, needs to finish first before this one runs. And I only did this so to separate these, so they don't all run at the same time and have any like conflicts because it's creating the same integration runtime multiple times. That's why I ran them sequentially, but that's how that works. So like this job will only start running when these two jobs complete, is how you can do that. So a neat little thing you can do in GitHub Actions. And now, how do we run multiple versions and multiple operating systems of our Python script? So you can do this runs on, and instead of Ubuntu or Windows, you can actually do this matrix.os. And then again, this is important, this $ bracket in the space, OS space, bracket. This is saying we're going to run a matrix of different operating systems and potentially Python versions or whatever you're going to do. Then you're going to put this strategy, and then down here is this max parallel. And I have this set to 1. By default, this means that whatever combination we have set up here, it's going to run in parallel at the same time. And if you have this max parallel of 1, this means run it sequentially. So if you see here in these versions, if I have a max parallel of 1, this is the Ubuntu operating system, and we're going to run the Python version 3.9. this max parallel 1 means run this first. Once this finishes, then run the 3.10 version, and then run the Python 3.11 version. If I had max parallel of 2, that means run these 2 versions first, and then when they finish, then run this one. And again, by default, it will run all of these in parallel if you don't have that listed at all. So that's how you can run them one at a time or in parallel. And then if you see here, you can specify what your combination is going to be. So that's why we say, I want to run the on an Ubuntu operating system, and I want to run Python versions 3.9, 3.10, and 3.11. That's why you see those 3 listed here all on Ubuntu. Now, if you wanted to run multiple operating systems, you could do something like this. You can go, and let's say you wanted to run like Windows, right? You can run Windows, latest. You can also run like Mac OS, but we'll just do Windows here for right now. And then what this will do is this is like a multiplier. So what would happen then is instead of just running Ubuntu on 3.9, 3.10, 3.11, it would also run Windows on 3.9, 3.10, 3.11. So you'd have 6 jobs that would be run, not just 3 with Ubuntu when you add this Windows here. So that's how that works. And this fail fast means is listed as false right now, because I have it listed here. What that means is that if, when it first runs Ubuntu in 3.9, if this were to fail, then stop these other jobs. Like, don't run these other jobs if you're kind of running them sequentially. It would fail fast. I'm sorry. This is fail fast false. This means that if Ubuntu 3.9 failed for some reason, like the Python 3.9 version failed, since it's false, still run 3.10 and 3.11. Like, still continue on, even though this fails, run through everything. If this was listed as true, that means that if Ubuntu 3.9 failed, again, this is run sequentially, then stop and don't run 3.10 or 3.11. That's what this fail fast means. Then the next step is, again, we check out our code because it's a new job, and then we run this name, and you can see the version we can actually specify is this matrix Python version. So it'll say which version is running at that time. And again, we use that same action that we used in the previous step to set up Python. I just put this in here because you can actually create an ID on jobs as well, which I'll use in this cache. So I just put this as set up Python. It's not going to do anything here, but just know you can actually set up IDs for jobs as well that you can use later on, which I'll show you. Then here, we're going to use this Python version, and we use this matrix.python version. So we're actually going to grab, because this is the ID, right? This is that piece of it, the matrix, and then we're going to have the Python version. So 3.9, 3.10, 3.11, and that's what's going to run through all those. It's going to get all those jobs. So that's how that piece works. And so if we see our action here, when it ran, if you see it ran the Python version, right, and it set up 3.9, it set up 3.10, and so on, and then it ran it. So that's how you can run multiple versions at the same time or one at a time. Then this last piece is how to cache dependencies. So how this works is you can actually go in, and let's go back to our workflow here. Okay, and if you see here, in our multiple versions, I have this cache set up. And that's this step that uses this cache action, which again is that like prepackaged code. And I put this ID called cache because we're actually going to use this later on. If you see here, I'm actually going to cache the Python location. So each versioned Python location, so 3.9, 3.10, 3.11, I'll explain why I do this versus a different way that you might see in some other documentation. I think this is really kind of a neat little trick. And what this is the key is what it's going to cache on. So it's going to like save this key. So it's going to say, when you run the workflow again, it's going to say, hey, does this key exist? If it exists, here's the cache we want to use, and then don't reinstall everything, again. And the key is actually going to be this runner OS, so like Ubuntu or Windows, whatever you have set up here. Then I have Python. You can name this like whatever you want, right? Then I have the environment Python location, right, as part of the key. And then it's going to say like Ubuntu, latest, 3.9, 3.10, 3.11 are the keys for each one. That's going to use this expression hash files. This is a GitHub expression, and it's going to hash our requirements.txt file, where we have all of our packages we want to install in Python. And the reason why we do this is because this hash file is actually going to create a random string that we can then use to store as the key. right, in this test1. So it's going to create this random string in this test1. So if we ever were to change our requirements.txt file, if we added like more packages or remove some packages, it would create a different like hash. So it'll create a different key, like random string, so it knows that it's different. It needs to update it in the cache. That's why we kind of use this piece here. This requirements file is just listed here. I have listed here, and I just have the one package here, but if you could have like multiple packages or whatever you have. So let's see how this works in action. So what we're going to do is we cache the information, and then we have this step that says installs dependencies. Then we're going to say use an if condition, that if the step, the cache step, so again, this ID, that's why this ID is important here. It's grabbing this ID. If it's saying this, the output of this step, if the cache hit does not equal true, meaning that if it can't find this key, if this key doesn't exist. So if we're in this the first time, then it doesn't exist. This will list as like false, but if this is not true, meaning it's false, then install the requirements.txt file and all the packages in there. But if this cache is true, then use this cache, and it will actually skip this step. And won't install all those libraries because it's going to be listed in our cache already and it's already saved. Then again, we just run our Python script. So what that looks like is, if you see I ran this a couple times already, when we run our cache, it's actually going to say that it actually found the cache. And it was restored successfully because we ran this more than one time. Again, the first time you run this, it will install those libraries the first time and say cache not found. But then after that, it will do it. And this is good for a week. So after a week, if you don't run this workflow again for like a week, then the cache will expire. Otherwise, it'll be good. Then if you see the key was that Linux, right? That's Ubuntu. Then that Python that we had listed there. Then the version that I showed you. And then this is that hash file of the requirements.txt. So if you added any more packages, this would change that random string. And then this test1. So that's how that works. That's why this install dependencies was actually skipped. But it still ran. It actually ran. That's why you don't see that requirements, like those request libraries installed here, because it actually found it in the cache. So that's super helpful, and it will save you a lot of time going on. And again, it just created that new IR1 again, is how that worked. So again, that did it for all the versions here. So if you see you're on multiple versions, it skipped all of those installs. So it like found that cache for each version, right? So one more time, I'll show you. If you see here, this found the cache for the 3.11 version of Python, if you see here. So yeah, that's how that piece works. Then the last piece that I'm going to show that's kind of a neat little thing is, I remember that's why I had this environment Python location as the path. Because if you actually look at the documentation, it will list this as the path to use. But the issue is that if you see here, if you use different operating systems, you actually have to vary the path. So if you use the Windows latest operating system to run your Python script, you actually have to use this as the path versus this cache pip. So if you don't want to create some if statements or change this every time for different operating systems, you can actually use, and that's what I did here, right? If you had to do that normally, right, you'd have to use this on Ubuntu. But if we used Windows, you have to change this path. That's why I actually used this environment Python location. That means it'll dynamically grab the Python location. So we actually don't have to add in different paths for each one. So if I run this on Ubuntu, run this on Windows, run this on Mac, this will all work because it'll grab that Python location. Just kind of a neat little trick to save you a lot of time and a lot less code that you have to write. So yeah, I hope this has been helpful. That's all I wanted to show today. And yeah, thanks for your time.